Okay, we're ready to wrap it up by talking about how to find holes in our functions and how to graph the results. So we get holes in our functions if we have the same factor in the top and the bottom. So if we have the same vertical asymptote and 0 in our function. So in order to figure out if we have the same factors in our function, we do have to take a look at both the numerator and the denominator of our expression and factor them to see if any of the factors match. So the first thing I'm going to do is factor the numerator. The denominator doesn't have to be factored because it's already as simple as can be. To factor my numerator, I'll find two numbers that multiply to 4 and add to negative 4. Those numbers are going to be 2 and 2, and if they're both going to give us a negative 4, they have to both be negative 2's. I end up with x minus 2 times x minus 2, and the denominator is a grand old x minus 2. Now, I have a whole bunch of factors that match, but the only thing that matters is that one of them matches with the numerator and the denominator. So I have a matching x minus 2. This x minus 2 will give me my hole. So if I solve it, I'll find out that x equals 2 is where my hole is. So I have a hole at x equals 2. And it comes from taking my denominator and setting it equal to 0. So my hole is at x equals 2. I would like to see what the graph looks like with the hole in there. So all I have to do in order to get that to happen is to take my matching factors and cancel them. My equation will look like whatever I have left. So it'll look like the line x minus 2, but it will have a hole in it at x equals positive 2. So let's go ahead and take a look at what this graph looks like. This is in slope-intercept form, y equals mx plus b. My slope value is the invisible 1 that's being multiplied by x, and my plus b is the minus 2 that's being subtracted from the end. And remember that b is my y-intercept. So I'll actually start graphing using my y-intercept. So let's go ahead and start graphing with that negative 2. I'm going to go to my graph, go down 2. That's my first point. Now all I have to do is use my slope to get the rest of my line. My slope is the number 1, which means I have to go up 1 and over 1. Up 1 and over 1. Up 1 and over 1. So these up and over 1s here, these are going to be my line. And I can go down 1 and over 1 in the opposite direction. So this is the graph of x minus 2. Now our function looks just like x minus 2, except that we have a hole where x equals 2. So I'm going to go to x equals 2 on my graph, which is right here. I'm going to erase that point, and I'm going to replace it with a hole, which is just an open circle. And that's it. That graph is finished. Let's take a look at our last problem. It is technically question 26. It was mistyped as 27 on the review, but it is the last one either way. All right, we're looking for holes, which means we're looking for common factors in the numerator and the denominator. So let's go ahead and factor. In this case, both my numerator and denominator have to be factored, and they both have a GCF. The greatest common factor in my numerator is the number 4. So we're going to factor that out, and we're going to write down everything left once the 4 is gone. 4x divided by 4 is just x. 20 divided by 4 is 5. There we go. Let's factor the denominator. It has a GCF of, that wasn't a good line, here we go. It has a GCF of 2. So let's take 2 out of both terms in the denominator. 2x divided by 2 is x, and 10 divided by 2 is 5. And wouldn't you know it, we have an x plus 5 on top and bottom, which means that's where my hole is going to come from. So we take that x plus 5, we set it equal to 0 to find my hole, and my hole is going to happen when x is negative 5. So I have a hole at x equals negative 5. Now all we have to do is figure out what my graph is going to look like once that hole's gone. So I cancel out the common factors, and my equation is going to look like 4 over 2. Now that can be simplified. 4 divided by 2 is just the number 2. So this graph is going to look like y equals 2. Y equals 2 is a constant. The parent function for a constant is a horizontal line. So basically, this is still kind of in slope-intercept form, y equals mx plus b, but the only part of it we have is the plus b. That means that the slope is nothing. That's why I have no x. It's being multiplied by a slope of 0. That's why it's a horizontal line. A 0 slope is straight across. If we think of slope dude, when he's going straight across, he's saying this is 0 fun. So that's a 0 slope. So the plus b, that positive 2, that's where I touch the y-axis, positive 2. And that also tells me where my entire line is, positive 2. That's it. That's my whole function, positive 2 in both directions. Now that's what y equals 2 looks like, but I have a hole in this function. So the very last thing I need to do is find out where that hole is. It's at x equals -5, so I'm going to go to the left, 1, 2, 3, 4, 5 spaces. I'll go up to where my function meets the equation, right there, boop, it's gone, and I'll replace it with my hole. There you go. That's it. My graph is finished. If you have any questions about the review, please message me on Remind. Please watch these videos, work together. Let me know if you have any extra questions. Good luck.